April 1942. Somewhere in the icy expanse of the North Atlantic, German reconnaissance planes spotted something utterly bizarre. On the horizon, far from the familiar convoys and steel warships of the Royal Navy, loomed a structure that defied logic. It wasn't a battleship, it wasn't an aircraft carrier, it was ice. From the air, it looked like a colossal, frozen fortress, a floating monstrosity carved from the Arctic itself. German intelligence officers were baffled. Reports described an object larger than any ship ever built, capable of carrying aircraft, ammunition, and provisions. It was rumored to be nearly impervious to torpedoes. How could a vessel built entirely of ice sail the Atlantic? They wondered. How could it support planes and withstand bombardment? The answer lay in a vision that bordered on madness, a plan so audacious it could have only come from the mind of one of Britain's most inventive and unorthodox war strategists. This is the story of Project Habbakuk, the secret British experiment to build an aircraft carrier out of ice. A project that left the Axis powers speechless. A project that merged genius, desperation, and the impossible. By early 1942, the United Kingdom was facing one of the most critical threats of World War II. German U-boats prowled the North Atlantic with devastating efficiency, cutting off vital supply lines from America to Britain. Merchant ships laden with food, weapons, and raw materials vanished beneath the waves almost as fast as they could be replaced. Every convoy risked annihilation. Every sailor faced near certain death at the hands of stealthy, underwater hunters. The British Admiralty and Prime Minister Winston Churchill were desperate for a solution. Traditional naval vessels could not be produced fast enough, and steel, the lifeblood of any navy, was a scarce and precious commodity needed for tanks, ships, and aircraft. Something radical was required. Something that defied conventional naval logic. Enter Geoffrey Pyke, a brilliant but eccentric scientist, journalist, and inventor. Pyke was the kind of mind that saw possibilities where others saw impossibilities. He proposed what most considered sheer lunacy. Why not build an aircraft carrier out of ice? At first, the idea was met with ridicule. Ice? A ship made of ice? Wouldn't it melt the moment it touched the ocean? Wouldn't it be brittle, fragile, and utterly useless in combat? Yet Pyke had a plan. He wasn't suggesting plain ice, he had developed a revolutionary composite material later named Pykrete, a mixture of ice and wood pulp. Pykrete was remarkable. Unlike pure ice, it was extremely strong, resistant to shattering, and could withstand bullets and even torpedoes. It had a tensile strength far superior to steel at Arctic temperatures and, with careful maintenance, could survive in the open ocean indefinitely. Perhaps most astonishingly, if it cracked, the material could heal itself over time. Churchill, ever the risk-taker and admirer of bold ideas, was intrigued. He famously called Pyke's proposal a project that combines the courage of youth with the madness of genius. Soon, the British government authorized an experimental program, pouring resources into testing the feasibility of an ice-based warship. Initial prototypes were built in Canada, far from the prying eyes of spies and saboteurs. Engineers and scientists labored in freezing conditions, mixing ice and wood pulp, shaping it into slabs and blocks that could be assembled into floating hulls. The first models were small, mere fractions of the intended full-scale vessel, but they demonstrated the extraordinary durability of Pykrete. Tests were nothing short of astonishing. Bullets ricocheted harmlessly off the thick composite walls. Attempts to break the ice with small torpedoes barely dented the structure. Unlike steel, which could buckle and rupture under repeated assault, the frozen material absorbed impact and redistributed the force across the hull. The practicality of such a vessel was staggering. Imagine a floating airbase in the middle of the North Atlantic, immune to German submarine attacks, capable of launching reconnaissance aircraft and fighters to scout the seas, protect convoys, and project power far from land-based airfields. The strategic potential was enormous. Yet, for all its promise, the project faced enormous technical challenges. The ice had to be maintained at sub-zero temperatures, requiring sophisticated refrigeration systems. It needed to resist the constant pounding of waves, the corrosive effects of saltwater, and the heat generated by machinery and aircraft on deck. Every detail, from the thickness of the hull to the placement of reinforcements, had to be meticulously calculated. Despite these obstacles, the dream of a floating fortress carved from ice captured the imagination of Britain's military leadership. It was audacious, it was brilliant, and, most importantly, it terrified the Axis powers, who had no idea such a creation was even possible. Project Habbakuk was more than a weapon. It was a symbol of British ingenuity, of scientific daring, and of a nation willing to turn desperation into invention. In the icy waters of the North Atlantic, something remarkable was taking shape, something that would leave the German and Italian navies completely speechless. By mid-1942, Project Habbakuk had moved from the realm of theoretical musings to practical experimentation. The initial success of Pykrete prototypes in Canadian laboratories prompted the British Admiralty to invest in a full-scale test model. A remote frozen lake in Alberta became the secret testing ground, far from prying eyes or enemy spies. Engineers began assembling a massive, wedge-shaped ice vessel nearly 60 feet long, a fraction of the intended aircraft carrier size, but enough to evaluate structural integrity, buoyancy, and durability. Each block was carefully crafted, with wood pulp mixed at precise ratios to prevent cracks and increase resistance to impact. The process was painstaking. Blocks had to be frozen under controlled conditions, and the team constantly monitored temperature to maintain a frozen matrix strong enough to bear weight. The first series of tests were deceptively simple. Workers drove trucks across the ice, measured the hull's flexibility under weight, and simulated wave pressure with mechanical pistons. Bullets were fired from rifles and machine guns at the hull. To everyone's amazement, the ice held firm. Where steel would have dented or cracked, Pykrete absorbed the impact. A bullet would bounce off, leaving a tiny, almost imperceptible mark. Even concentrated bursts of machine gun fire caused no catastrophic damage. Next came the torpedo simulations. Scale models of torpedoes were detonated near the hull in shallow water, testing whether ice could survive explosive shockwaves. To engineers' delight, Pykrete absorbed the energy, distributing the force across the hull, leaving the prototype intact. These early results suggested that, in the Arctic, a full-scale ice aircraft carrier could withstand attacks that would destroy conventional ships. Churchill was briefed on progress personally. In typical dramatic flair, he reportedly asked, "Gentlemen, do you realize you may have built a ship that the Germans cannot sink, cannot bomb, and cannot board?" His enthusiasm carried weight. Soon, funding was approved for a 2,000-foot-long supercarrier, large enough to carry 60 aircraft, complete with a flight deck, hangars, and storage for fuel and munitions. The proposed vessel, codenamed Habbakuk, was a marvel of engineering ambition. The design called for a 1,000-foot-wide, wedge-shaped hull, allowing aircraft to take off and land even in rough seas. Submerged refrigeration units were to circulate frigid water through the hull, maintaining the ice's structural integrity in open ocean conditions. Steel reinforcements would be placed sparingly enough to secure machinery and aircraft, but the vast majority of the ship's mass would be frozen Pykrete. At the same time, engineers explored innovative construction techniques. Unlike traditional shipbuilding, where dry docks are essential, Habbakuk would be built on floating platforms, using prefabricated ice blocks assembled like massive Lego pieces. They even experimented with ways to repair battle damage at sea. Frozen slabs could be patched and refrozen in situ, allowing the ship to heal itself. The implications were staggering. Imagine a vessel that could loiter in the North Atlantic indefinitely, impervious to German U-boats and bombers, a floating fortress carrying planes to hunt and destroy submarines before they reached convoys. The sheer audacity of the idea captured imaginations in London and left Axis intelligence scrambling for answers. Unbeknownst to the British, German reconnaissance was already buzzing with rumors of a strange British weapon. Early reports, intercepted by U-boats and spies, described a massive, ice-like vessel capable of carrying aircraft. Initially, German officers dismissed these claims. Ice? A floating aircraft carrier made of frozen water? Surely, it was propaganda, an exaggeration to scare crews into inaction. But Allied intelligence had a knack for feeding disinformation as well. Photographs of large, wedge-shaped ice structures, carefully staged and photographed, were leaked through neutral channels. German engineers and strategists were baffled. No conventional naval architect had ever seen or even considered the possibility of a combat vessel built primarily from ice. In Berlin, Admiral Raeder and his top naval engineers held emergency meetings. Blueprints of steel carriers and U-boats were compared. Calculations were made, but nothing could explain how ice could carry hundreds of tons of aircraft and machinery. Questions went unanswered. Could such a vessel survive in open waters, amid waves, wind, and Arctic storms? Could it absorb torpedo strikes, shelling, and aerial bombardment? How could the British possibly supply and maintain such a colossal frozen construct? The mere uncertainty created strategic panic. U-boat commanders were instructed to increase surveillance, but reports were conflicting. Some pilots claimed to see a massive white structure glinting in the polar sun. Others dismissed it as optical illusion, sea ice, or misidentification of conventional ships. The British cleverly capitalized on this uncertainty. Using disinformation campaigns, they exaggerated the intended capabilities of Habbakuk. Rumors circulated of a ship that could carry hundreds of fighters, launch strikes across the Atlantic, and sink U-boats on sight. The Germans, already stretched thin in the Atlantic, were forced to divert resources to investigate a threat that might not even exist yet. Meanwhile, engineers in Canada pushed forward. Full-scale models were tested in lakes and cold storage facilities. Experiments measured resistance to gunfire, torpedoes, and structural stress. Each success only confirmed what Pyke had long believed. Pykrete was the material of the future, strong, resilient, and capable of doing what steel could not. In London, Churchill personally visited the laboratories. He walked among enormous blocks of Pykrete, examining scale models and mock flight decks. According to reports, he was delighted and astounded, joking to staff, "If this works, we'll have an ice ship that laughs at German torpedoes and makes U-boats look like tin cans." The Axis powers, still struggling to comprehend the scale of British innovation, could only watch and wait. For them, the spectre of Habbakuk represented a weapon that transcended conventional warfare, a psychological as well as material threat. The project had already succeeded in its first mission, confounding the enemy and buying time for Britain's convoys. By late 1943, plans for the full-scale Habbakuk were nearing final approval. The ship was intended to be 2,000 feet long, 300 feet wide at the beam, and 200 feet high, a floating fortress larger than any conventional aircraft carrier of the era. It would carry 60 aircraft, fuel, munitions, and a full complement of crew. At its heart, the vessel would be Pykrete, reinforced with steel, insulated with cork and wood, and maintained by massive refrigeration systems pumping frigid water through the hull to prevent melting. However, as engineers moved from blueprints to practical assembly, reality struck. Building such a colossal frozen vessel was far more complicated than anticipated. Transporting thousands of tons of ice and wood pulp to remote construction sites in Canada required specialized cranes, barges, and storage facilities. Every block had to be frozen slowly to maintain uniform strength, and even minor fluctuations in temperature could cause cracking. Additionally, The logistical challenges of turning a laboratory-scale success into a sea-going behemoth became apparent. The refrigeration system alone demanded continuous power, precise circulation, and redundancy, without which the ship could lose structural integrity in hours. Engineers also struggled with weight distribution. A miscalculation could lead to catastrophic rolling or even splitting along weak seams. Worse still, as the team scaled up, unexpected hydrodynamic problems emerged. Ocean waves exerted far greater stress than the controlled lake tests. Calculations indicated that Habbakuk, in rough North Atlantic waters, could experience forces equivalent to hundreds of tons of pressure on certain hull sections, risking fractures or catastrophic failure. Simulations suggested that, even reinforced, Pykrete might slowly deform under prolonged oceanic conditions. British strategists were undeterred. Churchill insisted on continued development, convinced that the psychological effect on Germany alone justified the expense. He argued that even if Habbakuk never sailed, the threat of an indestructible ice carrier would tie down Axis resources. Yet, as practical obstacles mounted, engineers increasingly questioned feasibility. Another pressing concern was enemy air attack. While Pykrete could withstand bullets and small shells, it remained vulnerable to sustained bombing. A determined Luftwaffe strike could, in theory, melt or shatter sections of the flight deck with incendiary devices or bombs. Countermeasures such as steel reinforcements, water sprays, and double-layered ice slabs were proposed, but each added weight, complexity, and construction time. Ultimately, by 1944, Britain faced a stark choice: continue the massive and costly construction of a vessel whose combat survivability remained untested, or redirect resources to proven warships and aircraft. Engineers, despite their enthusiasm for innovation, reluctantly acknowledged that Habbakuk might remain a concept rather than an operational reality. Though Habbakuk never reached operational status, its influence on the war effort was profound, primarily through its psychological and strategic impact. The very idea of an ice aircraft carrier caused German intelligence and U-boat commanders to reconsider Atlantic operations. Reports of floating Arctic fortresses forced the Axis to allocate additional reconnaissance, divert resources, and plan for hypothetical attacks that would never materialize. In practical terms, the experiments yielded technological innovations that extended far beyond Habbakuk itself. Pykrete's properties, strength, durability, and slow melting were applied in Arctic infrastructure, temporary airstrips, and iceport construction. Lessons learned from large-scale frozen structures informed future projects requiring temporary but resilient materials in extreme climates. The project also demonstrated the effectiveness of combining industrial ingenuity with psychological warfare. Even an uncompleted prototype had forced the enemy to react as if the vessel existed, illustrating that in total war, perception could be as powerful as reality. Churchill later remarked in his memoirs that the Habbakuk project represented the spirit of British engineering under fire, a testament to audacity and imagination during desperate times. By the war's end, only a few small-scale prototypes and laboratory models survived, preserved in Canada and Britain as symbols of ambitious wartime innovation. Naval historians today regard Project Habbakuk as one of the most audacious what-if stories of World War II, a testament to the lengths nations were willing to go to gain advantage and baffle the enemy psychologically and materially. The Axis, in the end, never confronted a full-scale ice carrier, yet for months, the mere rumor of Habbakuk reshaped strategic calculations, diverting attention and resources. It remains a case study in how creativity, industrial capacity, and the manipulation of enemy perception can reshape warfare without firing a single shot. Even decades later, engineers and military strategists marvel at the concept: a floating, aircraft-carrying iceberg, defying conventional naval warfare. The legacy of Habbakuk is clear: innovation sometimes lies not in what is built, but in the audacity to imagine it. By mid-1944, prototypes of Project Habbakuk had provided critical insights, but the realities of wartime logistics and strategy became impossible to ignore. The largest prototype, a 1/10 scale model tested on a Canadian lake, had performed impressively under controlled conditions, with the Pykrete resisting bullets, small artillery, and gradual melting. Yet scaling it to operational size revealed a host of insurmountable challenges. The refrigeration system, originally designed to maintain structural integrity, required enormous power and constant monitoring. Even minor malfunctions could result in partial melting, compromising both stability and flight deck operations. Engineers realized that maintaining the ice at sea, subject to fluctuating weather and ocean currents, would be logistically overwhelming, demanding fuel, manpower, and infrastructure that Britain could not spare in the final years of the war. Additionally, advances in conventional naval vessels and air power lessened the strategic necessity of Habbakuk. By 1944, long-range Allied bombers and escort carriers were increasingly effective at countering U-boat threats, diminishing the need for a floating Arctic fortress. The Royal Navy, after careful deliberation, concluded that resources would be better allocated to proven platforms, rather than a frozen experiment that, while innovative, carried enormous operational risk. Churchill, ever the visionary, accepted the decision with characteristic pragmatism. While disappointed, he acknowledged that Habbakuk had already fulfilled one of its primary goals: to seize the imagination of the enemy. German intelligence had allocated considerable effort to track and analyze the project, diverting attention from other theaters. The psychological effect of Habbakuk, its sheer audacity and almost mythical size, had succeeded beyond expectations, demonstrating the power of perception in wartime strategy. The cancellation did not diminish the scientific and engineering breakthroughs achieved. Pykrete's properties were studied extensively, informing later developments in cold climate construction, emergency shelters, and experimental material sciences. Engineers refined techniques in structural reinforcement, thermal insulation, and modular construction that would influence post-war projects. In essence, Habbakuk became a laboratory of extreme engineering, testing the boundaries of material science in ways conventional ships could never do. Though the Habbakuk aircraft carrier never sliced through the Atlantic, its story endures as one of the most audacious and imaginative projects of World War II. A floating fortress of ice and wood, designed to carry aircraft, resist bombs, and challenge the U-boat threat, it might have been impossible to realize fully, but the very concept reshaped strategic thinking on both sides of the conflict. The Axis powers, confronted with reports of a colossal ice carrier, were forced to react as if it were real, allocating resources, modifying plans, and factoring an imaginary threat into naval strategy. In a sense, Habbakuk defeated the enemy without firing a single shot, illustrating the immense value of innovation, audacity, and psychological warfare. Today, historians and engineers look back at Habbakuk not as a failure, but as a symbol of limitless creativity under pressure. It represents the capacity to imagine solutions that defy conventional wisdom, to challenge the limits of materials, and to use industrial ingenuity as a weapon. In museums and archives, preserved prototypes and blueprints tell the story of a vessel that existed more in imagination than in steel, yet left an indelible mark on wartime engineering and strategy. Churchill's gamble and the engineer's relentless determination remain a testament to the British spirit of innovation, daring, resourceful, and capable of leaving even the Axis powers speechless. In the end, Project Habbakuk proves that sometimes the greatest victories come not from what is built, but from what the enemy believes might exist. And while the ice never sailed, the legend of the ice aircraft carrier endures, a chilling reminder that human imagination can be as formidable a weapon as any battleship, bomber, or tank.